Okay, hello. This is a presentation I gave at the New England Canadian IPM meeting. A group of extension and research people from Canada, New York, and New England come to this meeting every year up in Burlington, Vermont in the middle of October. This year, obviously, it was a Zoom meeting, but I thought I'd share with you this kind of off-the-cuff presentation I gave to that group. It's a comparison of 4 on-site weather stations and 1 virtual weather service as data sources in 2020 for the apple scab infection period model. We call these DSSs, or decision support systems. And the weather data was from the UMass Orchard in Belchertown, Massachusetts. Daniel Cooley was a cooperator on this talk. He provided some input. Some things I didn't like, but and I didn't include, but anyways, and we're both with the University of Massachusetts Amherst. Okay, so how we're looking at apple scab infection periods using the model inputs, the model decision support system inputs. And I used 4 hardware-based weather stations here at the UMass Orchard in Belchertown. Belchertown 2 was a rain-wise weather station. Plain old Belchertown is an onset U30 weather station. And then I have Orchard Watch North and Orchard Watch South, which are onset RX 3000 weather stations. Now all these are connected to NEWA, the Network for Environment and Weather Applications, which runs the DSS models based on these 4 weather stations. And I also was looking at RIMpro, which is a cloud-based decision support system that has the apple scab model. Plain old RIMpro was using the Belchertown 2, the rain-wise weather station sent to it by NEWA. And RIMpro MB was using MeteoBlue.com, a source of virtual weather data. So those were the apple scab infection period model DSS inputs. Now I made some assumptions to begin with. One, we had a clean apple orchard at the beginning of the season, meaning there was really virtually no apple scab at harvest last year, so the orchard was clean. A green tip for all the DSS models started April 1st. That was the start of ascospore maturity countdown for all. For NEWA, scab infection periods were taken directly from the NEWA table, the apple scab infection period table, and ended when primary ascospore maturity was 100%. For RIMpro, only if the RIM value was greater than 100 was it deemed an infection period needing a fungicide. And ascospore maturity and release zeroed out had to be zeroed out within RIMpro for the end of primary. For fungicide sprays, all infection periods required a protectant spray, and infection periods during the height of ascospore release also received a post-infection fungicide. So regarding these assumptions, you know what they say about assumptions. I will leave that at that, but those are some assumptions going into how I interpreted the data, the model output, primary infection periods, and spray timings. So for example, Belchertown 2, which is a NEWA weather site, weather station, remember the maturity started April 1st. So beginning April 2nd, we had an infection period, April 13th, April 26th, as indicated by these red arrows, April 30th, May 15th, May 23rd, and June 11th was for the last infection period spray after ascospore maturity reached 100% for a total of 7 infection periods. That's an example for NEWA Belchertown 2 using the rain-wise weather station. For MeteoBlue, RIMpro, for example, I'm using the MeteoBlue example, although the weather station data fed through NEWA would be the same. They had different results, but this is just an example. Remember this MeteoBlue. So remember I said the infection had to be above 100 on the RIM infection value scale on the y-axis. So you can see 1, 2, 3, 4, 5, 6, 7 red arrows where the red infection value rose above 100. So those were considered primary infection periods, how I interpreted RIMpro. All right, so I laid these all out in a spreadsheet beginning at the beginning of the primary infection periods, beginning at primary when ascospores were released at green tip. So the red squares with the X in them are infection periods. This is running from April 1st through May 31st. You can kind of see the first four kind of all run together, but the two RIMpro models kind of, varied quite a bit from the rain-wise infection periods. There was some differences within the rain-wise infection periods. There was a bigger difference between RIMpro and RIMpro Medial Blue. And I'll give you a summary of this. You don't have to hyper analyze this, but just to give you an idea of how I looked at infection periods. And then if you'll remember, I said that at the beginning of any primary infection period, we had to put a protectant spray on. So you can see kind of the yellow squares at the beginning of every infection period. And then out around May 1st, where through May, the middle of May, where the primary season was probably at its peak, infections required a protectant spray and a post-infection spray with some kickback. So I won't hyper-analyze this right now for you, but to give you an idea how I did it. And then looking at June, this is how it panned out in June. Note at the end for NEWA, in general, 100% maturity was reached by the end of May, the 7th of June on one of them. I think that was plain RIMpro. No, excuse me, that was one of the Orchard Watch sites. But then for RIMpro at the bottom there, you'll notice that infection, the primary wasn't zeroed out until the end of June, early July, which made a difference in the number of infection events. But in summary, looking at the lower left there, you can see that Belchertown 2 had 7 infection events, 8 spray events. Belchertown alone had 10 and 12. Orchard Watch North had 7 and 9. Orchard Watch South had 9 and 11. And then RIMpro, the different DSS, for the NEWA data fed with the on-site weather station only had 3 and 3. But Medial Blue, the virtual weather data, had 7 and 7. Now, I don't think there's a huge difference amongst the NEWA weather stations, hardware weather stations, from 7 to 10 infection events and from 8 to 12 spray events. Yeah, difference, but not a huge one. But you can see the RIMpro DSS had considerably less infection periods overall, particularly when using the hardware weather station. And Medial Blue had some more comparable with NEWA hardware. If I was doing a statistical analysis on this, I would want to do some contrasts here to compare, for example, the NEWA DSS and the RIMpro DSS, and then within RIMpro, do a contrast between those two. I think you'd find some significant differences. However, I can't really do that, so I won't. Anyways, that's the summary on the lower left. Just quickly, remember, I had 7 infection periods for RIMpro using Medial Blue, but if we were using the NEWA weather station data, there was only 3 infection periods. So that's kind of interesting. That kind of tells me there was a difference in how RIMpro was interpreting the weather data, or how different the weather data was between the weather station and Medial Blue. I'll mention they also use 2 different leaf wetness models, so that could have been a factor. My intent, though, was not to investigate what caused these differences, just see if there was a difference. I wanted to mention at Clarkdale Fruit Farms, another site, we also had virtual weather data fed into RIMpro, and you can see there were 6 infection periods. And we also had hardware weather data, and there was really only 3 infection periods. So that kind of mirrors what we saw in Belchertown with the RIMpro using weather station data and RIMpro using Medial Blue data. All right, so questions, lots of them. The infection periods range from 3 to 10. Fungicide sprays range from 3 to 12. Again, that's a big difference. Were there hardware-based weather station differences, in particular leaf wetness, rain gauge? Was there a site micro-location difference? These weather stations, the 4 weather stations, weren't all right next to each other. There is some topography there. I frankly don't think that amounted to that big a difference, but it could have. RIMpro versus NEWA. NEWA was generally more conservative in declaring infection periods and thus spray events. But the assumption of the RIM value for greater than 100 for infection may not be valid. In fact, is it invalid? I don't know. It's a judgment call. But RIMpro is supposed to be a more, I can't think of the right word, a more tangible, has some more nuances that make it a different decision support system. NEWA is kind of black and white. RIMpro has some nuances. And then a big difference in RIMpro onsite using weather station data versus RIMpro MeteoBlue. You know, my feeling is MeteoBlue may not be so good with precipitation, thinking it rained when in fact it did not. You know, was the intensity of the precipitation taken into account in the model in terms of the amount of spore release? Lots of questions there. And I have no intention to answer these questions I just want to say, look, using different models, using different weather stations, we came in with arguably different actionable results, which is kind of a problem, it seems to me. I think digging into the data would be good questions for a master's student, not for me, and I'm going to quit doing this. Why? I don't know. We've been through this before. Back in 2016, we gave a talk during this very identical meeting comparing decision support systems for primary apple scab management. And then we actually published this in Fruit Notes, UMassFruitNotes.com. You can go look for spring 2013. Not sure, we probably had a couple different studies in there, but if you want some closer look at that, you can. So with that, that's my presentation. If you have any questions, feel free to email me, jon.clements@umass.edu. And thank you for paying attention. Have a good afternoon.